the crux of my talk is going to be actually focused on raster-based processes. Basically, as everyone knows, binder jetting and raster-based processes like DLP, SLA have been on the rise. And the idea here is manufacturing needs to be enabled by software and compute. So what does that really mean? It means that the manufacturing, we're at a unique point in time where the manufacturing hardware has actually surpassed the software. We have machines that can print at a higher resolution than most software can even make. We have machines that can print faster than you can do build prep. And we have machines that can print all kinds of parts that no piece of software can even necessarily even design. And this all stems from three key concepts. So on the raster side, we have one key kind of industry standard, 1-bit monochrome, 2D polygonized rasterized images, right? If all the data that's going to these high-powered machines, which are capable of significantly more, are limited to 1 bit, right? We're losing control, right? And the idea here and the simple solution would be to just simply add color and grayscale, to go much beyond where we're going. The second issue that is a recurring theme is compensation. Regardless of whether you're dealing with a powder bed fusion process or a sintering process, which requires a green part, compensation is the name of the game. Hours and days are spent simulating it, and materials are qualified to go handle this. This basically reduces the freedom of parts that we can use and the freedom of the materials that we can use, and clearly the answer needs to be a generalized anisotropic compensation API. And finally, we're back to the ever-increasing march to how all machines are getting bigger, faster, more resolution, and the people who are using them are generating more and more complex parts. In short, the answer here is power. And to summarize it, the answer here is to use the engine that we've been developing to give back power, freedom, and control in all of these processes.